Welcome. Thank you very much for coming. My name is Juliano Moraes. I work for Netflix. And today I'm going to talk about UI components in Redux. So I will start talking about the organization that I work for inside Netflix. I work for the UI engineering at Netflix, and we are responsible for bringing innovation for our physical production. And these are the people that make our TV shows and movies. I hope you are aware that Netflix, we have been creating a lot of new content, original content. And just to have an idea about the scale of what we are doing, only in this year we are investing tens of billions of dollars in new content. So we want to bring innovation and make these productions more effective. If you see the picture, this is a picture of a real production that I went and talked with people in order to understand the problems and help them. And in order to do that, we recently built one app, one mobile app to help the productions to do their jobs, and the name of the app is Protocol. We built this app with 4 engineers in 3 months. Actually, we built 2 apps, one Android and one iOS, in 2 programming languages, Kotlin and Swift. And we have 1 code base and some shared code. And we were able to implement more than 50 UI components. So this is not a very simple app. It had a lot of features that we needed to implement. We needed to implement authentication. We needed to implement all the data fetching. We had more than 10 screens. We had complex lists, forms, CRUD operations, which can get a little bit tricky. So this is a sneak peek of the app. This is our iOS app running. If you see in the top, we have a project selector, which is Glow Season 2. Anybody here watched Glow? No? Okay, cool. So we just released Season 2. When they were making the show, they used this app. And the idea of this app is to help them with the scheduling of the shooting days. So every day that they go to shoot, they have a set of milestones, they have the scenes that they are going to shoot, and if every crew use these apps, they will be able to know when something is happening, they are going to get notifications, messaging, and that will make their days a little bit nicer and easier. And here's the Android app. In the site, the UI looks exactly the same. And here I'm highlighting some orange boxes that you can see how we created UI components for this application. Every single thing you see in screen are UI components. The season selector is a UI component, the buttons, the header of the list itself, all the items in the list. And when we have to write 2 different apps in 2 different platforms, actually, it's the same app, but we have to rewrite twice. So people start to ask about multiplatform. And that's a good question, right? Why don't we use a multiplatform framework like Flutter or React Native or this kind of stuff? But one thing that people forget sometimes is it's very likely that the team that you asked to build these apps, they are very experienced teams in native development. So we had years and years of experience with our native frameworks, Android and iOS, and we knew the IDE, we know the programming language and everything. So it's a little bit hard to, I mean, we could do that, but we already know a lot. So there is a concept that we created when building this app, which is multi-platform by architecture. And what I mean by that is we write once, and we translate from Kotlin to Swift, and from Swift to Kotlin everywhere. The idea is we have 2 teams, one iOS team and one Android team, and we have the same set of features. And the UI looks like the same. So what we do is we figure out how to implement a feature in one platform. And the hard part when you are implementing something new is to figure out the business logic, the data fetching, all this strategy. Once you have that, it's just writing code. So what we do is we write one feature in one platform, and then the other platform follows that and write the same feature. And when the second platform does that, it's just a translation. We translate from Kotlin to Swift, or from Swift to Kotlin. This approach allows us to keep the same features in both applications, and we can move super fast. So we had, in order to achieve that, we had the same data layer in both apps. We had the exactly same models. We had the same view models. And we have the same UI components in both applications, iOS and Android. So now I'm going to show you something that is very scary. That's an iOS code. If you've never seen that, this is how Swift looks like. And here we are representing a UI component. And we have the exactly same code in Android. And you can see that you can read that, even if you've never seen Swift before, or you've never had an iOS device, you can totally read that and it looks exactly the same. In this example here, it's a representation of a UI component. We have the render method in both. We have an interface on Android and a protocol on iOS. Now I will talk a little bit about state, the state of the UI components. I was here last year giving a call, and my main goal when I was here was to sell the idea of UI components and talk why the idea is good, why it helps a lot to implement UIs. So, and one thing that I said back there was the fragment is not your view. And I'm here again to say the exactly same thing. You should not consider that the fragment should be your view. If you are inflating more than a handful of Android views inside your fragment, there is something wrong with your architecture. You should think about UI components and separation of concerns and move the logic to organize it a little bit better. And since then, a lot of things happened since last year. So Google announced Compose on Jetpack, that it's their interpretation of UI components. Apple announced Swift components this year. And of course, everything started with React some time ago. And more component-based frameworks and libraries are being released every day. I'm very happy to see it happens, and it proves that the industry is moving into this direction. So now let's pause a little bit and talk about the architecture of this application. How we architectured that. We were able to have the nice opportunity to write the whole app from scratch because nothing existed. We didn't have to deal with legacy code or anything like that. We call this architecture Re-components because we have a mix of Redux and UI components. And the first layer that I'm talking about is the data layer. In our app, we used GraphQL to implement all the data fetching. And we have a data broker entity that is responsible for fetching all the data. And we use QuickType. If you're not familiar with QuickType, that's a very nice tool that allows you from a JSON file to auto-generate code. And it supports a lot of languages. It supports Kotlin, it supports Swift, it supports JavaScript. In our case, what we did is we used QuickType to generate our models. And then it forces us to have the exactly same models in iOS and Android app, which helps with the architecture. And then we have Redux. If you are not familiar with Redux, the main idea of Redux is unidirectional data flow. The data flows in a single direction. And we have the representation of state. And one thing that I was also very happy to see yesterday in a lot of talks, everybody was talking about state. And the UI should be a representation of your global state. A UI should be the function of a state. And if you have a take on from this conference, what I would say is stick with this idea. Every time you see a piece of UI, think about the state that represents that UI. That will help you to design applications. And then in the end, we have UI components. And the UI components, they are reusable. You can reuse in any screen you like. They are very testable. And testability is a very important thing for us. And they are composable. You can compose UIs using components that you created before. I will start a deep dive now. Start with activities and fragments. If you have a very complex fragment or a very complex activity, it's not very good in a separation of concerns architecture pattern, and it will be hard for you to maintain that code, to extend that code. So mainly what we want is the fragment should represent a screen of your application. And ideally what the fragment should do is instantiate a bunch of UI components. And here you can see that this screen has a toolbar in the top, it has a header, it has a selector, a list, and a bottom navigation bar. And if we have to create another screen, we can reuse the toolbar, we can reuse the bottom bar, and we might be able to reuse other components that we already have. So there are no business logic here. The whole fragment is instantiating components. And then what should be a UI component? It's a single class, and it's independent. This is very important. If you want to make that reusable, it cannot have dependencies or on other things. It's by itself, and you can reuse that everywhere. And this is also very important in our architecture. Every single component defines its own state, or if its own view model. What it means is we can define what the component understands and what the component cares about. I will talk a little bit more about that. And we have a single interface in every component called render. There is no other way to call a component instance. The only method that we expose is a render method that receives a state of type T, which represents the states that the component defines itself, or the view model. And also components, they dispatch actions. One thing that's good for reusability is you should not know about other interface. A component should not call any other methods from other classes. What we do is we have a button, and when somebody taps a button, we fire an action. So the component will say, somebody tapped me, I don't know what to do. Somebody will know what to do in the stack, and something is going to happen. But it's not the component's responsibility to implement the logic of the click listeners, or the drag, or any user action. And now let me show you some code. So in your left, you have our app, and the component that I'm going to show now is the one that's highlighted in red. That component, it has a date, it has a title, and it has a button. So the component has 3 Android views inside of it. Let's see how the code for that looks like. The first thing that I'm going to do is I'm going to represent a state of that component. And my state here is a Kotlin data class. This is very common to represent state, and the reason is data classes on Kotlin allow you to do a diff very easily. They implement equality for you, and then you can use that for other cool stuff later on. So here what I did is I defined that this component state has a shooting day object, which has the information that I need for my date and for my title, and it has a boolean, which will dictate if my button shows up or not. And then we are going to go to the class of the component. This is a list header component that receives a container. And the container is a view group where the component is going to inflate itself inside of it. And here is how we inflate a component. Ideally, every single component has its own XML layout. It means that you have a class that represents that component plus an XML layout. And then all the styles for that component will be embedded on it, and you can reuse that everywhere. If I need to add that component in any other screen, it will look like exactly like this. So I'm going to inflate that inside the container, and I'm going to initialize the Android views. So here you have 2 text views and 1 button. And for the button, we are going to set the click listener on that. And as I said before, the click listener does not have any business logic. It just dispatches an action. And here, as part of the action object, we are passing a route. Because what we want for this component, this button, is the user taps on that, and we want to send user to another screen. But we are not going to implement this logic here. This logic is going to say, after you execute this action, you route to another screen. And then the most important piece of the component is the render function. The render function is where you implement what's going to happen for that component. So the render receives the states that we defined for that component. And here we are going to grab the data from the state. We are going to check if the data is not null. And if the data is not null, we are going to set the date and the title. And then we go for the button. We check if we should or if we should not show that button. What dictates if the button should show up or not is the preferences, the permissions of the user. But here, the component doesn't care about that. It's just a Boolean. Or we show the button, or we don't show the button. And that's it. This is the complete code for this simple component. Now let's talk a little bit about layout. The component that I just showed, it uses a self-inflation approach. But we can have other kind of approaches to deal with layout. The second one is pre-inflated views. If you have a big XML that has a bunch of Android views and you have to align based on each other positions and all these things, and you want to use the Android editor to do that, you are free to do so. And instead of passing the container for the component, you can pass the inflated view. So you don't need to inflate inside the component. You just grab the view, but they will look like exactly the same. You still define the state, you still have the render method. And the third one is a self-inflation into a constraint layout. And this approach allows you to programmatically set the constraints and align your views accordingly. This is very useful for a UI that looks like our player UI on the Netflix application. This is how I implemented components there. We have a constraint layout, and we programmatically align all the views based on what we need to do. Now let's go to the Redux part. How the Redux and the components, they work together. Redux has a concept of a store. And the store is a global object that contains a state. That state dictates how your app should look like. And then, as I showed you, we have components. What happens is, every time the state changes, we call the render method of all the components. And here we use a subscription pattern that every single component, it's going to subscribe to the store. And when the state changes, we call the render for every single component that's subscribed to that store. And then the components will dispatch actions. For every user interaction, we are going to dispatch an action. And what the actions will do is, there is something called a reducer, which is a class from the Redux that is responsible for intercepting an action and generating a new state. Here we generate a new state. The state is immutable, so we generate a new instance of the state. We replace in the store, and we call again every single component render method. And that's the loop. That's what we call the render loop. So every time a component fires an action, the state is going to change, and every single component will re-render. But one thing to keep in mind is every time you hear about subscription on Android, you need to be very careful and think about the life cycle. Because you don't want the subscriptions to leak. In our case, what we use it is a pattern using the Android view model. And this is not, this is the view model from Jetpack. We have the component subscribing and associated to a view model that we can unsubscribe when the fragment dies. And we can be aware of the life cycle and prevent leaks. Here's to illustrate how it looks like. We have a store, and we have a bunch of components, and they are all subscribed to the store. But we might have different screens that components are part of. And the way that it works is, if a screen dies, we want to unsubscribe all those components from the store because they don't need to do anything. When a new fragment shows up, we subscribe again that components that we need to display in that UI. That's how we hook the lifecycle with the components, and all the components, they are lifecycle aware. Now let's talk about the render loop. So the render loop is what controls how and when a component will render. But we have a problem here, right? We don't want every single piece of the UI to change if the state changes, because the state, ideally, it's a large object and it's global. In the state, you can have the routes that the user is navigating to, but most of the UI, they don't really care about the route. We don't want to keep calling render every time the state changes. How do we prevent prevent that. And this is a key piece for our architecture. We need somehow to transform the global state into the component state and make sure that the component only renders when something that the component cares about changes. So let's go back to our component again. And here we are going to see how the code looks like. Every time we subscribe a component, we will pass the UI component instance, and then we have a transformation function which will transform the global state into the state that the component cares about. And if you look this example here, what dictates if the button will show up for the edit mode is the permissions of the user in the global state. So we have the states.user.permissions.hasWrite, and if that property changes, we are going to re-render this component. If that property does not change, this component doesn't really care. And we don't need to re-render that. It will have a nice performance, and it will avoid the UI of blinking all the time, every time the state changes. Now let's talk a little bit about advanced use case for components. Last year, I got a lot of questions. How do we use components inside a list? How do we plug that in a recycle view paradigm? So I'm going to talk about that. Ideally, what we want is a UI component could be part of the list if we need it to be part of the list. And it could live outside of the list. So the reusability portion will tell us that thing needs to be reusable outside of the list. And most of the libraries or frameworks, or they work with the list, or they work with outside of the list, we wanted one thing that works for both cases. And this is how the list and the recycle view case will work for us. We have the Redux store that will have the state, and we have a recycle view adapter that we need to be able to implement an Android recycle view. So the way that it works is the component list will subscribe to the store. When the state changes, we are going to render the component list. And then what we do is we call our adapter.update to change the data sets that we have if the data has changed from that state. And this update is a custom adapter that we wrote that will do all the diffs in the background thread. It will abstract away all the complexity from the recycle view, but it's still a recycle view adapter. We are not changing the framework. It's just an adapter that extends the recycle view adapter and has some nice stuff for the components. And then what happens is this adapter will be responsible for invoking the render function of every single item of the list. And this will work with all the recycling paradigm of the recycle view. We don't lose any performance here. We only call the render for that items that the adapter controls. And we still do all the recycling. But let's see some code. Let's see how the code looks like in a recycle view paradigm. So here we have a list component for our crew members. We show a list of crew people that are part of that production. And this is the component for that. We have a data set, and we have an adapter. The adapter uses our custom adapter. And one method that we need to override in the adapter is get component for list. And this is the method that's going to instantiate the item, the component that represents the items. And here we can have a list with a lot of components of the same type, or we can have different types. Based on the view type, you might want to instantiate another kind of components. And all these components, they are also reusable outside of the list. If for some reason I need to add a crew item component in another screen that it's not a list, I can easily do that. And then we have to inflate that item for that component to work in the recycle view. And then we have the render of the list. The render of the list will get the data from the state. It will map through, and it will set our data set, and then we call the adapter.update with that data. And that's pretty much it. There are no complications here. We abstracted away all the complexity from the recycle view, and that looks like exactly like any other component that we have in our app. But I will give you a sneak peek of how the adapter works. two main methods for the recycle view: onCreate view holder that we replaced by getComponentByList, and then we have the onBind view holder, which will call the render for the subcomponents. And here the new state represents calling the render for every single item of the list. And that's how the list works. We don't have to compromise with performance. We can still use components on it. And this is another use case. Another advanced use case is you might have cases that you do not want a UI component, but you still want to use the component architecture. In this case here, we have the navigation of application. We used components to take care of the routes and where the user is going. And one advantage to approach in this way is if you have to implement the classic navigation pattern, when the user taps a button, you want to navigate to another screen, that button needs to be aware or needs to have a reference for the fragment manager or for the activity. And in our case, the button doesn't know anything. The button just fires an action. So what we have is we have a navigation component that knows about the fragment manager, and the navigation component is responsible for routing users from one screen to another. Here's the state of the navigation. It cares about the route. We have a route in our global state. In that component, it only cares about the route. If anything else changes in the state, the navigation component will not do anything. But if the route changes, we are going to do something. In the implementation, and also we have the onBack press. So if the user press back, we want to use our own backstack, because in our case, we implemented the backstack inside the state. And that allows us to do very cool stuff in the Redux pattern. We can rewind operations, we can save all the states when the user is navigating, and when the user press back, we don't go to another fragment. We can just pop the previous state, and we can track exactly what the user is doing and have more granular navigation. So now it's the render implementation of the navigation component. And what we do here is when we get the state, when the state changes, we are going to invoke the fragment manager to replace that and send the user to the right screen, the screen that we want to send the user to. And that's our navigation component. Now I will talk a little bit about unit testing. Unit testing is very important for us. And one of the motivations why we build this architecture is to make unit tests very easy, very fast to implement. Most of the case, unit tests are hard. If you have a large fragment and then you have a lot of dependencies, you need to mock a bunch of stuff to write a unit test. That's not fun. It's a lot of pain. And people end up not writing unit tests. So one thing that the modular component architecture helps is easily write unit tests. And there are two approaches that we take for unit tests. As we have a render function for every single component that receives a state, we can easily instantiate a component, we can call the render function, and we can mock up the state in any way we want. We can write multiple permutations of the state and see how our component will react with all those changes. And the second one is the integration test. So the integration test, the idea here is we fire an action like a data fetching, and then we check how many times a component render was called. And then we test the integration of our Redux actions with the whole application state, and we make sure that we are not calling a component more times than we should. And with this approach, we were able to achieve 87% of code coverage. And that was pretty easy for us to do. It was not that hard. Here is a sneak peek of our code coverage that we have in this application. We have 87% in the components package. We have 76% in the whole package. This whole thing helped us a lot to write unit tests. And now let me show you how the code for a unit test looks like. Here we are going to use the same component that I was using in the previous examples. We are going to instantiate that component. Here there are no dependencies. We don't care about fragments, we don't care about lifecycle, we don't care about activities. It's just an instance of an object. And then we are going to test the render. We are going to call UC, which is our component, .render, and we are going to make up a state here on the fly. We could use mock libraries, or we could just instantiate the data class here. We can do as many different states we want. And then we assert what happens with the Android views inside the components. Here we check if that shooting on date was set in the right Android view, if my title was set in the right Android view, and we assert for visibility. And this pretty much covers 100% of the code that we have in that component. Now the second approach, how do we test the render count? We are going to invoke an action that will fetch some data. And here the way that the data fetching works is it's all async, and we are going to make a network request. We want to show a spinner for the user to know that we are loading the data. When the data arrives, we are going to hide the spinner. This is what this action is going to do. So the next what we do is we grab a component from the store. And we grab a component to be able to test how many times the render count was, how many times the render method was called. And in this case here is we are testing the loading. So we are testing if we should or if we should not show the loading spinner. And in this case, this component should be called 2 times. One when it's loading, and the second time when the data is there, we hide the spinner and we show the data. And this is how we assert how many times the render was called and the values of the state for these 2 times. The first time, the fetching data should be true, and the second time, the fetching data should be false. So now let's recap. Let's recap and talk about, first item is keep your fragments clean. If you have a large fragment, it's going to cause all sorts of problems for you. The second one is a good foundation is essential for the velocity of the team. If you have a good architecture, and I'm not talking about only this architecture, any architecture that you like and any architecture that works for you, it will make your life easier. And you could move, your team could move much faster if you have a foundation. In our case, every time we need to add a new screen, it's pretty easy for us because we create a new screen, a new fragment, and then we can add the toolbar components that we built before. We just add that to the fragment. We add the bottom navigation bar there. We can reuse a bunch of stuff that we already built for other screens. And if you have to build new components, it's very easy to do so as well. And building new components will increase our library that is reusable, and tomorrow when we need to do something similar, we can reuse more stuff, and it's faster and faster. And the third one is components are here to stay. If you are not using components in your architecture, or if you are not thinking about this idea, I strongly recommend you to do so, because the whole industry is moving into this direction. All the companies are creating component frameworks, state-based, that's all here. And think about that if you are not already doing that. Pick the library that you like more, or just build your own. And the last one is, if you want to work closely with the movie industry, Netflix is hiring. You can bring some Android to Hollywood and help the people that are making our awesome TV shows and movies. So thank you for coming. I appreciate that. I would love to hear feedback. You can send feedback to me on Twitter, tag me there, send me a private message. And we have some code there for you to look. So if you go to this GitHub repo, you can see a full example of a list using components and how everything works. And if you really like that, you can just grab our library and use that. So my friend David Henry wrote a Redux library in 150 lines of code that it's part of this library, and all the helpers for the components are there as well. You can use the list adapter, you can use components inside lists, outside of lists, and the library is 32 KB. So it's very, very small. And now we have time for some questions, if anybody has any. Thank you very much.